Back to great. Thanks, Stephen and Kevin. It's a real pleasure to be here today. Cascadia Scientific is a great partner of AWS, along with a bunch of other people and organizations within the mining industry. So it's really interesting to see some of what not only Cascadia, but Equinox and Piam are doing. And I wanted to talk briefly today about how I believe the cloud can enable the next generation of mining. 15 minutes is not a long time. I've been accused of being able to talk underwater before, so I'll try and stick to the limit. So a very brief introduction. My name is Ben Weaver. I'm a Principal Partner Solutions Architect here at Amazon Web Services. I am dedicated to the mining and minerals segment, and that often surprises people when they hear about Amazon and mining, and usually they first think about crypto, but that's not the case. We have a small team of people who are drawn from the mining industry and who focus exclusively on every spectrum or the whole spectrum of the mineral processing and extraction industries. So that's traditional mining, it's quarries, aggregates, cement, fertilizers, and so forth. I specifically focus on technology vendors who service the mining industry. So that's people like Cascadia Scientific. And I help them build on and grow with the AWS cloud to improve their products and how they deliver solutions to their customers. A little bit about AWS, for those of you who might not know, we started in 2006, and it happened when Amazon realized that they developed a pretty unique capability in dealing with this little website known as Amazon.com. And what they did is decide to offer this expertise to businesses through web services, and in the process effectively started the modern cloud computing movement. And this is a pretty good thing, because with that expertise, it helps us deal with the vast quantities of data that we're not only seeing today, but we're going to see into the future. And IDC say that by 2025, industry globally is going to generate 163 zettabytes of data per year. A zettabyte is 1 trillion gigabytes. I can't even comprehend just how much data that is. But putting the forecasts aside, if we look at what companies today are doing with the data that they've got, we quickly realize that really only a small percentage of them are actually effectively using that data. And everybody is saying that they want to become a data-driven business. They want to use data to drive decisions throughout their entire businesses. The number of people who are actually successfully doing it right now is still relatively low, or if they are, they're having success in certain areas and only focusing on specific things. So as we continue to see a continued investment in mining technology, we're going to see the quantity and types of data that we store increase, and the challenges associated with that become more complicated. And the really important thing is how we look at and analyze that data. And I think both Kevin and Piam's talks really touched on some of the mining specific applications that we can use. And not only is the volume of data going to grow, but the types of data that we need to store and process will change also. We're going to start to see vast quantities of streaming data. We're going to see images, video, unstructured text, and so forth. And these are all going to need to be managed and exploited in order to drive improvement. And this change, these different types of data are going to present challenges to how we've traditionally approached analytics. And we're going to need to adopt new methods in order to deal with it, including things like real-time analytics, natural language processing, image recognition, and machine learning. Obviously, machine learning is what we're talking about here today, a lot of it. And putting the technology aside, in a lot of ways, data science today is really more of a people problem than a technology one. There is a shortage of skilled people who have the expertise to actually do this work. And therefore, optimizing the time that they have available is really critical. When you waste effort on what we at AWS call the undifferentiated heavy lifting, and that is all of the things that an application or system needs in order to function. You can think about it as all the stuff at the bottom, but doesn't necessarily add a competitive advantage. That takes people away from actually solving business problems. So here at AWS, we like to use the mining and metals flywheel, and it represents in a very simplistic high-level way how the various processes throughout the mining value chain relate and fit together with each other. Now, no doubt everyone on the call has an appreciation for how these stages influence the next, but the way the industry has traditionally executed is that these feedback loops are very loosely coupled, and they're usually downstream only. So we see there are inefficient processes that add significant delay that limits how tightly we can couple these processes. The overwhelming response from industry is that we want to tightly couple these processes in order to dynamically optimize across the entire mining and also supply chains. And this means that the quality, the timeliness, and the analysis of these vast quantities of data is going to be more important than ever before. In response, most miners, or all the miners, they're seeking to stand up data platforms in order to support these efforts. But the vast majority of these miners, they don't have the resources or expertise required to build a data infrastructure to address these challenges. And I would argue pretty strongly that they shouldn't. Like, their core business is mining, and they're not technology infrastructure providers. So we need to take a new approach. And this is where the cloud can step in and provide that technology foundation that's required in order to enable this vision. A very brief introduction for cloud computing. It is, in short, the on-demand delivery of IT resources with the pay-as-you-go pricing model. And a really good analogy that I like to use is electricity. And when you walk into a room, you can flick the light switch and be assured that the light is going to come on, but you don't concern yourself with how that electricity is generated or distributed to you. You just use it when and as needed, and you pay for what you consume. This diagram here provides a generic overview of the range of cloud services available. And this is all the way from infrastructure at the bottom to very advanced machine learning and AI services at the top. For example, AWS has over 200 different services today. So you can pick and choose these as required in order to build a data platform to support whatever it is that you're trying to achieve. Ultimately, by leveraging the cloud and removing all that undifferentiated heavy lifting, all that stuff at the bottom, a miner can focus on what their core business is, that is mining. So the benefits of the cloud go well beyond just the provision of services and technology. At AWS, we like to broadly categorize the key benefits of cloud computing into these 6 points. I'm going to focus on the first 4, and you'll notice that none of them actually mention a specific technology or service. They're all about how an organization can fundamentally change how they operate and therefore adopt technology. So a bit of clarification. I just want to elaborate on a few terms that are important because you'll probably hear about these a lot. First of all, scalability. And this is the ability of a system to remain operational with an acceptable level of performance as demand changes. And traditionally, scalability has been looked at in a one-way scale-up approach. And this leads to an increased upfront capital cost. It leads to a very slow response to demand changes, and it often results in capacity that is wasted a lot of the time. Elasticity is the ability for this scaling process to be dynamic, and not only scaling up, but scaling down. And to the end user that is consuming the service, the resources available appear to be effectively unlimited. What is really important is that you can be assured that when you need the capacity, it will be there and be available. And then finally, agility. And agility isn't just about how a particular resource is deployed based on business demand, but it's really a fundamental change to how an organization can think and operate. And when you remove that undifferentiated heavy lifting, and remember that's all the stuff at the bottom that doesn't actually solve the problem, you free people to focus on understanding and addressing the business challenges. And I think there were just some fantastic examples in the previous presentation. We're not talking about technology there, we're talking about solving a business problem. So part of this agility and part of this change in thinking is how we look at how software is delivered. And when you look at a traditional software licensing model, you are typically charged upfront based on some assumed value creation over the lifetime of the product. And this is usually whether or not you actually use it. So there might be functionality that you never touch, but often you still pay for. Most businesses, they want to see a more direct correlation between the technology investment that they're making and the business outcome that they'll receive from that. And this is where cloud-based software as a service consumption models can really directly tie that output value with the cost. It adds transparency to how you're paying for your software. And you only pay for what you use and when you use it. And then finally, when you move to these new delivery models, you lower the barrier of entry. And because you're tying that output, that consumption, directly to a specific task, it allows for these costs to be moved around. And certainly there's a very important aspect of moving that capital into operational cost. But I think more importantly, it allows organizations to better respond to changes in their business environment. So if you don't need to use a particular piece of software for some time, you simply don't use it. This is a journey, and I thought it was worth mentioning this because I think a lot of people get a bit daunted by what a cloud migration is. We typically recommend that a small project is chosen as an introduction to cloud native development, and this builds a foundation that can be leveraged in the future. Legacy applications can be migrated and modernized or perhaps retired. It all depends on what your technology environment looks like. But the key thing is that the innovation never stops. Once you're in the cloud, you can take advantage of the new capabilities that are continuously offered in order to reinvent and transform. This is an iterative process that never ends. So, tying all of this together, Cascadia Scientific have a really fantastic example of how they're leveraging the cloud, and that's going to be elaborated on a bit more. So I wanted to find another example that was relevant to the group here. And Maptech is a name that is likely familiar to a lot of people on the call here. No doubt many of you use some or much of their software. And apologies to any geos in the room, I'll probably get this description a little bit off the mark, but a really critical aspect to mine planning is domain modeling. And this is the process of taking that assay data from drill holes and creating a 3D model of an ore body. And these models are absolutely fundamental to the value, or maybe lack thereof, of a mine. So having a high quality model that's up to date is absolutely critical. In the past, building these models was a largely manual process. It required a geo to interpret the data, run some discrete simulation software, a lot of levers to pull. It was time consuming. So what Maptech did was take a new approach, and they applied advanced machine learning leverage the massive scalability of the cloud, and can now complete this process on demand automatically in minutes. And the end result is operations that could previously only update these models infrequently, maybe once or twice a year, can now do this effectively whenever they want. The example here, to provide some context, includes about 4,600 drill holes. There's almost 4 million data points. The strike length is about 4.5 kilometers long by 1 kilometer wide, and it results in 120 million blocks, total volume of about 1.7 billion cubic meters. And this model is generated in under 4 hours. And it's generated using a consumption model where you pay a per minute charge for the model generation time. And this is just such a massive fundamental change in how this process is completed, and will have an absolutely huge effect in not only the downstream processes, but also how the value of that asset is viewed. And this is just one small step in the mining process. Imagine if we did this to everything. So if we go back to the mining and metals flywheel, version 2.0, we're going to see how this very tight integration starts to occur between different processes across the entire value chain. And this is going to allow us to develop new capabilities and perform deep optimization before a hole is even drilled in the ground, or while the ore is coming out of the pit, or while the plant is receiving the material from the pit. I think the industry generally has an undeserved reputation for being slow adopters. That's certainly not true. Technology is present in every mine around the world today, but certainly they have been slow to take a strategic view, an enterprise-wide approach to technology adoption, ignoring basic back office IT, and keeping pace with innovation, both the what and the how. I believe that cloud computing will provide miners with not only the infrastructure, but more importantly, the mindset and the agility to quickly respond to dynamic conditions. And this is going to allow them to drive the improvements required to mine safely, responsibly, and sustainably going forward. So with that, thanks for listening, and we'll see what questions popped up.
Thanks, Ben. Okay, so we have a lot of questions coming in on the chat here, and we'll start with Yijin. So how is AWS going to help solve the problem of remote sites' internet instability, unavailability, as on-prem infrastructure won't face these issues and cost less?
Yeah, so AWS has a number of solutions available to help support edge computing. And if we go back to this diagram here, you notice down the bottom we've got edge services, edge compute and storage, and managed infrastructure. And effectively what this does is allow you to extend the cloud onto your local site. And there are a few different ways that can be approached. The AWS Snowball and Outposts products fit into this bit here. So if you'd like to know more, just hop onto our website and it's all there. But again, we're sort of trickling the cloud down locally, and where that latency or those latency sensitive applications are required, we can address them.
Great. Next one, Abbas asks, how do you compare the reliability and security and costs of running the model on AWS and other options out there?
If we're talking about the domain MCF, the Maptech model specifically, I can't comment on the cost analysis because I'm not aware of it. But I do know that they've had a really positive reception with the product. There is an extensive amount, a bunch of case studies on their website. You can see it down here at the bottom of the slide. So certainly to them, they view this as a big change, a fundamental change to how they deliver software. And I'm really optimistic that other vendors throughout the industry will follow the lead and take a similar approach. One of the absolute key things I mentioned was lowering the barrier of entry. You can try this and you might be out of pocket a couple of $100. Like if it doesn't work, that's it. So it really allows you to increase the pace of change and your ability to try different things.
Great. Next one. So, second here. Joao asks, how is AWS managing security and different regional compliance requirements?
Yeah. So AWS has a very large physical presence, and we do this through what are known as regions, which are a collection of availability zones. And this is getting into a bit of specific AWS terminology here, but basically we put data centers in different countries around the world. And by doing so, if you are subject to a particular set of compliance requirements, or you just prefer to keep data in a particular place, you can choose to use that region or that availability zone. We're constantly looking at how we can improve that footprint, how we need to respond to changing government requirements, and so forth. So in the vast majority of cases, there isn't an issue with moving to the cloud from that perspective.
Brian is asking, how can a mine get started on the cloud? What are the steps that you suggest?
Yeah, like I said, if we go to this cloud journey here, the best way is to start small and find something with a well-defined outcome that you can use to start upskilling your teams, start understanding what cloud-native development looks like, and get comfortable with the technology that you'll be using. Now, that's, of course, assuming that you're developing directly on the cloud. My role focuses specifically on partners. So if you look at the likes of Cascadia Scientific, their solution is built on AWS, but that's completely transparent to you. You don't have to worry about the implementation details. You just get the benefit of all the things that the cloud provides.
That's great. I'm just reading through a lot of the questions here that are coming in. Let's try and find another one here for you.
I've got a question, Steve.
Sure.
So Ben, I mean, certainly there's very different types of industries serving mining in general. So there's mining primes who might own the operation. They may or may not operate it. Then there's contract operators. Then there's companies like ours, technology providers. Is it fair to say that tech providers, companies like Cascadia, a number of FMSs, Maptech, are leading the way in terms of cloud migration, or are you actually targeting those three segments of the mining vertical independently? And are you seeing different trends and certainly different velocities for migration?
Yeah, if you look at so I mentioned the back office IT things, email, productivity tools, SAP, that sort of thing. AWS has a very strong body of experience with moving those types of things to the cloud. And that's sort of low-hanging fruit, right? This is stuff everybody uses. It's a pretty common, almost cookie-cutter type development approach. But when you start looking at some of these other things, like what Cascadia does, like what Payam was talking about in condition monitoring, in fleet analysis and analytics, that's a bit more specialized. And that's where our team really comes in to advocate for those people and support them in moving to the cloud. It is a challenge because everybody is dealing with constrained budgets. We've got limited resources. We have competing priorities and that type of thing. But we certainly are seeing that the smaller players are more nimble and they are responding to this shift towards the cloud. They are leading it, and eventually the laggards, the big guys that might have a bit more inertia to sort of turn they're going to have to follow. They won't have a choice. This is the way of the future, in my belief.
Steve, you want to come back off and
Yeah,
ask
sure.
that question?
Next one is Greg asks, what trends do you see occurring in the industry in the next 5+ years that could accelerate adoption of the cloud by mining firms?
Yeah, and connectivity is often one of the first things that people bring up as a reason to not migrate to the cloud. I don't think it is as much of an issue now as it used to be. And certainly, if you look at a lot of the tier 1, the tier 2 miners, they have excellent connectivity. They have the infrastructure in place that could support a cloud migration today. But there is definitely a bunch of mines that are not well served from a connectivity perspective. And we can solve that in 2 ways. We can move the infrastructure closer to the edge. We are developing these capabilities through Outposts, through Snowball, or we need to improve the connectivity. And to me, something like Starlink, Elon Musk's project, it's going to be an absolute game changer. It's going to provide very high bandwidth, very low latency connectivity effectively on a global scale. And this means that there is no excuse. There's no reason not to do this. The connectivity, when there, will facilitate this migration towards the cloud. From an infrastructure perspective, to me, it doesn't make much sense anymore to keep running data centers on premises. There's a lot of cost. There's a lot of environmental sustainability concerns around the effectiveness of this type of thing. So as these come to end of life, as you start need to doing refreshes, I think that will also push people to the cloud further.
And we've got time for one more, Steve, I think. Do you have one or?
Yeah, if you got one loaded, go for it. But we have time to squeeze in a few more.
Yeah, I was going to ask in the mining side of things, when you see this transition, this cloud migration, are you more seeing cloud native solutions that are things that are being developed and hosted in the cloud that are built to do that, or are you seeing more of kind of a pick and place where you go and grab some existing software and you just run it on an EC2 instance, or what is the trend saying now, and where is it headed?
It's both, and a wholesale migration is very difficult, and there are people that have pulled it off. They do rewrite an application from the ground up. But if I go back to Domain MCF and Maptech, what they did was integrate this cloud functionality with their existing desktop application. So they're using the familiar interface that all of their users are trained with already, and they're putting it as a front end to the cloud capabilities of the Domain MCF product. So people don't even know that they're using the cloud. It just happens. And this is a really great way to introduce the concept and the capabilities of cloud computing. Certainly, a wholesale lift and shift migration is a good first step for some, but it should never be the final solution. It should always be the start of a journey towards a modernization effort that leverages a cloud-native architecture.
Awesome. Lift and shift were the words I was searching for, but didn't come to me. All right, Steve, go ahead.
Yeah, let's get one last one in. Albert asks, don't you think that modeling in the cloud and paying for the hours used will impact negatively on entry-level guys, since experienced guys will definitely use less modeling time, or any training space for new modelers?
That's a big question. I don't know if I can effectively answer that off the cuff. I think if you look at the software capabilities more generally, this is disruption. This is what happens in the technology industry. And when you have more nimble players that are coming in and disrupting the well-established ones, or rather the established players are leaving themselves open for disruption. if they don't start taking advantage of these capabilities, they're going to find that their customers simply move to competitors that do provide these capabilities. So these are market conditions at play, and it's something that's available to everybody. The capabilities exist today. Please come and talk to us. Let's start working on this together.
One last one, final one. Lucy asks, how do you view the transition of legacy data into a format usable for cloud processing? We know there's to be a lot of potential and value of these data sets, sometimes in paper format, exclamation mark.
Yeah, and there are many answers to this question. It really comes down to the what. But we can use things like image recognition and natural language processing to take a lot of this old data and digitize it. And a great example I saw recently was assay data that was recorded on paper. And this particular customer used some machine learning and image analysis to digitize that largely automatically. I think at some point you need to question the value of bringing some of this old data in. Certainly in some cases it may be useful, but in other cases, is it going to actually give you any additional value? There is a bit of an attitude, or historically, there has been an attitude of, let's just collect everything and then worry about what we're going to do with it later. We probably want to start thinking up front a little bit more about, if we collect this data, what value will it give us? And also, when will this data no longer be of value? So if we capture it, if we store it, if we analyze it, at some point, do we need to discard it? Or do we need to just archive it off and retire it? There are a bunch of different AWS services. I'm not going to do a pitch here, but we do have a bunch of services that can help in this space. Something you might want to look into a little bit is what's known as the lakehouse architecture, and there's plenty of information on this on our website.
Yeah, and if we didn't get to your question, there's plenty of opportunity after the webinar to be able to ask questions to Ben.